Okay, we're in section 17 of the notes of chain rule. Chain rule is going to be very difficult for some students to understand. It does require some patience and practice on your end. The way I'm going to achieve this rule is by using what's called a local linearization. We'll go through that. Now, by the way, depending on what textbook you have, they might use local linearizations too. I'm not going to say it's a proof, but it's a way to understand the derivation of the chain rule. And the chain rule is listed over here. We'll go through the notes in a second. We'll certainly go through examples as well. When we even go through examples, we'll do the examples that are being presented in the notes. And as I do that, of course, our intent is to get through the lecture portion so we can get to the examples. It's going to be slow going, though. For a lot of students, this is a struggle. The struggle needs to be met if you need to plan to move forward. The chain rule is going to be used often enough that you could not get through this course without knowing the chain rule. Now, what rules have we done so far? Quite a few rules, but we got stuck sometimes. And when we got stuck, we had to do a lot of work to get a derivative. And now we're going to say, is this rule over here is going to lift a lot of the burden off our backs, because we'll have a new rule that allow us to do derivatives of even more complicated problems that we couldn't do prior. So we got to do that. And the way we do that, we can go to the whiteboard and I'll basically talk through the notes. Give me a second to share the whiteboard with you, though. All right, we're looking at the notes on the whiteboard now. So, the first thing I'm going to talk about is a local linearization. And I'm not saying that every book does this. And, certainly you may look at your book and say, they don't even discuss this one chain rule. They have a proof of the chain rule in the appendices of some books. And that's fine. You can look through that if you like. All right. The more you look at, the more you read, the more you study, the more you're going to start to appreciate the subject. And that's true with any subject you're studying. But what I'd like to do is just, maybe walk through this, all right, local linearization. Before I do that, I want to read this over. It says, in class, I've derived some simple rules for differentiation. We've derived many simple rules. How do we do that? By the definition. We applied the definition to the function we're looking to do, and we got some simple rules going, which is great. We know some really nice simple rules. You don't want to lose sight of those simple rules. However, I want to be honest with you. What's going to happen now is they're going to ask you to derive a rule or memorize a rule that's a little bit tough to derive. So they're going to talk about local linearizations now. At least I am. I notice a footnote over here, and I want to go over the footnote with you. And I want to, sort of like it, the footnote. And when I'm looking at the footnote, I want to kind of see if I understand what they're saying in the footnote. And I want to tell you what they're saying. They're saying something about, you've certainly seen this before. That's a definition, right? So I'm going to say if H is near the zero, I'm going to say this quotient, this different quotient, if we're near the zero, is going to be approximately the same as F prime. Right, I'm going to keep moving along. And again, we're near the zero. So I'm going to say F of X plus H minus F of X, sort of like this over here. All right. And then I'm going to say F of X plus H equals F, I'm sorry, I didn't mean to say equal, approximately equal F of X plus H F prime of X. So it says something remarkable happened over there. I have a function of a sum. And what I'm doing, you're writing these things, and I'm splitting into two things now. And that's remarkable to me, that you could actually split that function of a single argument into two terms now, right? This is one term. Now I got two terms. All right. And it says, I don't think that's remarkable. I think it's remarkable. So what I claim over here is that they claim that sometimes this makes life easier for me, but sometimes it makes it a nightmare. So they say over here, if you were to do this to derive the product rule, you would certainly write this down, the definition. We've done that before. But do you remember how I did that? I kind of put a term in, took a term away, and then we looked at this thing. We finally found the limit of it, and we got this result over here. But I want to be honest with you. This over here looks more involved for me. It looks like it might be difficult to do. It might be tough. All right. So when I get claim over here, it's tough for that one. I don't recommend doing that. We've already done that many times before, by the way. I think I've derived that rule at least twice in two different sections. What I want to do is I want to move on to something new. Right. And the thing I want to move on to new is what you did in Math 119. You did compositions. So I'm going to say f of g of x really is a composition. Its f is being composed with the function g of x. And by the way, these compositions can go on, not just two things. You can do three things, four things, five things, so forth and so on. And what they claim is that the derivative of this guy over here, let me write this down for you. They're claiming the derivative of this guy, this composition, is easy to write down, but hard to understand. And it's going to be f prime g of x times g prime of x. I'm not saying we're at that level where we can understand how to use that, but I'm telling you, as it's written over here. What I want to do, though, I want to use this local linearization to do it. When I say do it, convince myself that that rule is correct. So what I'm going to do is go to the next page, and I'm going to look at this, and give me 1 second here. And I want to do the derivative using a local linearization. Right. I'm going to paste that thing I just talked about before on the side over here, because we're going to need that. All right. So before I do anything, what I'm going to claim over here is that I'm going to say writing the first line down should be relatively simple. And that's, let me point out what I mean by that. This here, I'm using my definition. That's all I'm doing. So what do I do? It's going to be, that the function evaluated x plus h minus the function evaluated x divided by h. That's not an issue for me. What's an issue for me is that can I get that f of g of x plus h? It's going to be tough for me. I'll be honest with you. I'll write it down for you. What I'm looking at is I'm looking at f. Whoops, I didn't mean to do that. I'm looking at f of g of x plus h. And I want to see if I can start to expand that using a local linearization. And we'll go back to notes in a second. So I got f of, it's going to be tough to write this down, right? So it's going to be g of x plus g prime of x times h. Now I got to expand this. Local linearization again. So if we can do that, it's going to be f of, let's see, g of x right? I'm just doing this over here, local linearization, plus f prime of g of x times g prime of x times h. That was a lot of work, wasn't it? I want to go back over the notes though. I want to see if I've met their milestone. And the milestone is going to be, was I able to expand it out? I'm looking at this line over here. I'm going to expand this a little bit later, but did I get f of g of x? Yes. Did I get f prime g of x times g prime of xh? Yes. And of course, the last term there is there. Now, something remarkable happens. I want to tell you what remarkable happens. This disappears. And that to me is remarkable. Then what am I left off with? I'm left off with that middle term, which looks really simple. It's f prime g of x, g prime xh over h. Now, what do I notice? The h cancels off. Can I do that limit? Yes. What's that limit? This thing over here. all right? How do I accomplish this? Local linearization. Was it easy? No. I'll be honest with you though. Look at your textbook, see how they accomplish that. All right, so we're done. Now what we're going to do is we're going to do this. We're going to try to, I'm going to say visually understand what they're giving me over here. It says, now we will learn how to use the rule. Now presenting you with the rule doesn't mean you know how to use the rule, but we presented the rule to you. Consider the function f of x and g of x given by the following graph and define h of x equal f of g of x. Well, I think we've done that before. We've already done that. And we know the derivative looks like this over here. All right. So I want to look at the figure they're giving me. And before I do that, though, I want to see that they want to do this over here. And I'll write this down. They want, let me write this, what this is. This is going to be f prime g of 1 times g prime at 1. That's what they want me to do. Well, you know what? I have to go to the next page to look at the picture. And I'm going to do one thing at a time. I want to do g at 1 first. All right, so I got to blow this thing up. And this is g. And I want to do g of 1 first. All right, I'm looking at g. Let me put out what g is. G looks like it's this curve over here. This is g. And I want to do g of 1. I'm looking at it, g of 1, I'm going to say it looks like the number 3 to me. So I'm going to go back over here and say g of 1 is equal to 3. So this over here is 3. I'm sorry, I misspoke. This is 3. I'm sorry about that. So let me write that down now. So what do I got? I got f prime 3 times g prime at 1. So now what I got to do? I got to do f prime at 3 now. Let me see if I can do that. And I want to tell you what f is. F is this function here. Like this. Wow, this looks like a tough one, doesn't it? All right. Let me draw my tangent line in there for you. Well, it looks like it might be tough to do, right? I know the slope is positive. I'm gonna say it looks, maybe it looks like, I don't know, 3/2 then. That the slope of this thing, m, the slope of that line, I'm gonna say roughly 3/2. By the way, when I say rough, I can't guarantee it's 3/2. I'm just saying it roughly looks like 3/2 to me. All right, roughly 3/2. So let me write that down. They said 4/3 though. You know what? I better do a better picture. I'm sorry about that. Because I really want to match your picture. And I'm gonna erase that. I'm gonna go backwards on this if I can. Erase. I'm gonna actually erase this over here too, because I want to get a better line. And I really mean that. I need to get a better line. So my line was too chunky there. This is tough though, isn't it? Let me take a look at that. Still don't know if I did a great job on that. No, I still don't think I got their line. Let me try again. This is probably trying to ballpark things. So what I want to do, I want to look at that curve. And I'm going to say I'm a tough down ballpark in it. But I notice that this thing, it's parabola, right? Let's talk about its graph. So I'm going to write this over here. I'm talking about the graph near 3. So I'm talking about f of x's. Let's put this over here. F of x, I can say it looks like a quadratic. All right, quadratic. And let's take a look at that quadratic there. Well, it's definitely opening upward. It's got a vertex at 1. So I'm going to put this down over here. So I'm going to say, something like this. X minus 1 squared plus 1. Let me see if that does it for me. And why am I looking at this parabola over here? So I'm looking at the point 4, and 4 would give me what? That would give me 4 minus 1 is 3, and 3 squared is 9. 9 plus, that doesn't do it. That'll give me 4. So I want f, I'm looking for this coefficient here, by the way. I want f of 4 to be equal to 4. Let's write this down. F of 4 is equal to a times 9 plus 1. I want that equal to 4. So let's keep writing this down. 9a. I'm sorry, that's 4. 9a equals 3. So a would equal 1/3. I'll put this down now. So f prime is going to be 2/3 x minus 1. And what would that be at 3? The slope be? Well, 3 minus 1 is 2, and 2 times 2 is 4. So it is 4/3. So the slope here is 4/3. Okay, let's go back and make sure we know what's written down over here. All right, so we just did this over here. This is 4/3. Again, remember, looking at the graph, trying to ballpark it, you may not get it exactly. That's why I had to go to the function. I had to look at it. Let's see if we can do g prime of 1. I don't know. Maybe that's going to be really tough too. Maybe I have to derive that equation too. Let's take a look at it. What's g prime at 1? It's right over here. Well, you know what? I think I can do this one by just putting in a triangle. Super simple. Super simple over here. What do you get over there? Well, it looks like, slope of this one here, slope of that line there would be what? 1, 2, 3, 4, 5, 6 over 2. Looks like slope is 3. I'll put that down for you. What do I get? 4/3 times 3, which would be 4. Done. Let's go to the next one. I'm going to get my eraser out. I'm going to erase all this stuff over here because I'm going to have to reuse the picture. Don't be discouraged. I know this is tough. We're not even at using a rule yet. Okay. Let's do h prime at 0. I'm hoping it's going to be easy for me. So you have to remember what h prime of 0 is. And certainly on the prior page, I have some memory here, but may not be great memory. That's going to be f prime evaluated at g of 0 times g prime at 0. Well, I got to see if I can do that. And what's the first thing I want to do? I want to do g of 0. Well, I'm looking at that, and g of 0 is right here. So what's this going to be? F prime evaluated at 0 times g prime of 0. All right. We have some memory here, right? So I'm going to do g prime of 0 first. And by the way, I think we just did that, right? That's going to be 3. I'm sorry, I didn't mean to do that. That's going to be 3. We just did that before. Now, do you remember we did this? And someone says, I don't remember anything about what you did. I think I derived the formula, right? You remember that? for that function f? Right, do you remember that? But if you don't remember it, I want to point out, we write this stuff down for you. And I'm going to go through the derivation again for you. Vertex is at 1, 1. That's true. I took this point over here as a good sample point for, what'd you get? 4 minus 1, which is 3. 3 squared is 9. 9 divided by 3 is 3. 3 plus 1 is 4. It works out beautifully. So let's write down f prime again. It's a lot of work though, isn't it? 2/3 x minus 1. And I want to know what f prime is at 0. What does that give me? Minus 2/3. Now, Grant, someone said, could I draw that in a picture? Yeah, probably could, but it might be tough. What does this give me? Minus 2. We feel good. All right, let's see if we can do this one over here. And by the way, I know it's difficult, but I got to write it down. What's h prime at 2? It's going to be f prime g of 2 times g prime at 2. One thing at a time. Let's see if we can do g of 2. What's g of 2? It's 6. What's f prime of 6? I don't know. Let's take a look at it. That looks pretty simple. I can say it looks like, let's see, 1, 2, 3, 4, 5, 6. That's the run, and 2, 1/3. What's g prime at 2? Let's take a look. This is 2. It's a sharp corner, DNA. This doesn't exist. Okay, let's go to the next one. A little more difficult. Let me erase this up here too. And I know it's tough. I'm getting a little better though. All right. Oh, by the way, when I say f is equal to this thing over here, only for the parabolic region. It's not for the whole function. All right. So let me take a look at this one over here. And you know, I gotta kind of write it down. It's composition, by the way. It's a different composition, not the same one. And this composition is g of f. So it's going to be, you know, the derivative of that's going to be g prime, evaluate f of x times f prime of x. So let's write this down one step at a time. And again, I'm using this over here. G prime f of 1 times f prime 1. One step at a time. Let's see if we can do f of 1 now. It's right there. That's going to be 1. Okay, let's see if we can do this now. Let's see if we can do g prime at 1. Well, g prime at 1 is this thing over here. And we've done this multiple times before. It's going to be 3. Let's do f prime at 1. I'm going to look at the picture. I got to plug in my battery though. Sorry about that. The battery goes wacky sometimes. Not wacky, it just dies. I have been out, haven't really been charging it for long. I mean, I haven't charged it in a long time, so I need to charge it. Okay, I'm charging it. It's tough though, I know that. So let's see, f prime at 1, right? I go back over here. Oh, that's easy. That's 0. What's 3 times 0? 0. That's done. Let's go to the next one. and K prime is 0 and K prime of 4. I'm getting better. Let's write K prime down. That's going to be G prime F of 0 times F prime 0. This is going to be G prime F of 4 times F prime at 4. Again, I'm getting a little better at this. What's F of 0? Boy, that's a tough one. But I think I know F of 0. What's it going to be? Well, F of 0, I'm looking at this now. And it's a parabolic region, right? What's that going to be? Let's see, 1/3 plus 1, 4/3. Go back over here. I'm going to write that down now. All right, what's G prime of 4/3? Let's take a look. Well, 4/3, I'll point it out to you, it's over here. And G prime is still that line, isn't it? And that line, do you remember, at 6/2, which is 3. So I can write that down. Where am I? Well, you know what? I think I lost sight of something. Where did that go? I got to write it down again. Sorry about that. I don't know where it went to. Sometimes I move things around. Oh, I'm sorry. I didn't write it down. So it's G prime. F of 0 is 4/3 times F prime is 0. And then we did G prime of 4/3 was going to be 3. And then F prime is 0. Let's do F prime is 0 now. That'd be minus 2/3. Minus 2. Let's see how we did. Next page. Minus 2. Let's do the next one. Again, get a little better at this. G prime. What's F of 4? That's 4. F prime at 4. Well, you know what? I think I know F prime of 4. It's right here. It's D and E. So what's this guy going to be here? D and E. Let's go to that. D and E. All right. Okay. I realize for a lot of students, this was almost pointless to them. And the reason is they say it's so complicated. I still don't understand how to use the chain rule. So what I'm going to claim over here is this just introduced the chain rule. Let me point out what I mean by that. What I'm saying is I have a composition F of G of X. What does this mean? F of G of X. I'm going to say the derivative of this composition, F of G of X. It's easy to write down. We derived the rule. It's going to be the derivative of F evaluated at G times the derivative of G evaluated at X. This could be multiply nested, but what we need to start to do now is to see these functions as compositions. This is going to require that you know Math 119. In Math 119, you did compositions. You need to recognize these compositions. Every problem you're going to do is going to be compositions. You're going to hear me use things like the outermost function, innermost function. What do I mean by outermost function? Outermost, innermost. You get the idea? Okay, here's the problem. This over here for a lot of students was really tough to get through. I'm going to say take home message. This is your take home message. Can you do that on these problems here? Good for you. What do you need to do first? Maybe look over this, look over. When we come back, we need to start doing examples. With the hope after we do examples, you're able to do examples on your own without me on your back. Okay, thank you.